So please let me know if there's any network problems. Those who just joined now, hi, hello. I think we can wait. There's someone that I need to. Okay. Mm, okay. Yeah. Let's start. If there's any network problems, please let me know. So guys, I'm gonna show you the first example. The examples I showed you the page number there. You see this example one on page 52. I don't know which study guide you're using, but it's your maths one, maths 3 study guide one. So I'm gonna explain the second order differential equation. I skipped that chapter there. This chapter, the applications, because for now they're not too much important and they're too easy. It's only few things that you need to know there. But the second order differential equation, it's a lot of work. It's too much. There's a lot of theorems and everything. So the first one that we're gonna do, the first example that we're gonna do, guys, it's your first order differential equation that has got different factors. So the first step, like for example, I'm gonna write that example. So for this example, you've got different factors. And then they ask you to find the the equation of that differential second order differential equation. They want you to find the equation of that. So we've got different factors for this one. So this example on page 52, it's normally written like this, but then you have to change it to auxiliary. So you have to change that equation to auxiliary. There's a lot of examples. I'm just showing you this one. I will do a lot of examples on focusing on this one. So, and this one, guys, it's equated to 0. This one, they call it a constant because 0 is a constant. You'll find equations where you've got d squared over dx squared plus dy over dx minus 2y, and then it's equated to something, to a number. So you will get to this one. But then in this case, we're gonna start with this one where it's equated to 0. Where it's equated to 0. We're gonna get to this one. But first, we need to do the one where it's equated to 0. That's where we're gonna start. I'm gonna show you this one. So this one has got different factors. The first thing that you do to solve this equation, guys, here's what you do. You find the auxiliary equation. Auxiliary equation. So auxiliary equation, you're gonna replace dy over dx with m. So where is dy over dx, you're gonna put m. So we're gonna take this thing here. Then you're gonna say m squared, right? Plus, because you see here everything is squared. So it's m squared plus m minus 2. You see there? You see there it's 2. There's no dy over dx. So you only write that coefficient. You see here the coefficient was 1, the coefficient here was 1 as well. In front of dy over dx it was 1. So let's say, for example, I'm gonna write it in purple so that you can see it. Let's say for example, the coefficient for this one, it was 2, then this one was 3. So it means here you're gonna have 2m squared, then 3m. Then this one, the coefficient, you only take that 2. You ignore the y. You only take the coefficient. Where is it? That's how they did this one. This one, you change everything to m. That's your first step. Then from there, you're gonna equate it to 0. From here, you find the factors. So you need to find the factors of this m. So you're gonna have m If you don't know how to find the factors of this, or you want to find factors using the easiest method, this is a method. It's a quadratic equation. You're going to say m equals to minus b plus or minus root b squared minus 4ac over 2a. This is an alternative method of finding factors. This one, we're going to use it. I prefer using this one for everywhere, in fact. But if you see that it's easy to find factors, there's no need for you to stress. You check if you'll be able to find factors or not. If you can't find them, use this quadratic equation. We're going to use this one when you have got complex numbers. So complex numbers is when you can't find factors. Maybe you've got negative square root of 36. Obviously, you're going to have to say 36i. That's where you're going to use it. We'll get to that. Where you can't find factors, we'll get to that point. For now, let's focus on this one. So guys, as you can see, you check if you can find the factors of this. Yes, you can. It's minus 1, it's 2. I first put negative on both sides, then I check. In order for me to get this, should I say 2 minus 1 or 1 minus 2? You check that. You check. So, as you can see, here I'm going to have to say 2 minus 1 to get the positive m. I'm going to say 2 minus 1. So it's going to be positive 2 and minus 1 to get the middle term. Then here the factors will be minus 2 and m equals to 1. That's your factors. These are your factors. Any question up to so far? Don't think there'll be any question. Yes.
Yes, what I see in my study guide 1, I'm not sure if I'm correct, but on page 52, I see the sum as d squared y over dx squared minus 3 dy over dx plus 2y.
Which is it? This one on page 52. Is it this example 2?
No, let me check the other because I think I might have opened
Okay.
the wrong thing. Let me try another one because that's what I see.
Let's write yours. Yours is, you're saying it's d squared y over dx squared.
Let me open it again. It's d squared y.
Yes.
Yes, minus 3 dy over dx. Plus 2y
Equals to
2 plus e to the exponent x. I'm not sure if that's what we're on right now. But
no. Those ones, it's the, we're gonna get to that one. For now, we are still doing the one. I think, yeah. Go to the first page of second order differential equation. Go to the first page of first order differential equations, because even if you go to the exercises for this one, this one is the basics of first order differential equation. You see there, we're gonna do this example. After that one, we're gonna do this exercise. There.
Okay. Because I think the numbering might be different.
Yeah, the numbering might be different. Yes.
Okay. Because my example 1, let me check. It's
go to first order. Where it's equated to 0.
Okay, because I'm on 2.1 second order. All right. In equation with constant coefficient. All right.
Yes.
Let me just
Constant coefficient. What's your example there?
Okay, 2.1 is second order linear equation.
Yes,
with constant coefficient.
Yes, that's the one. Yes, and then
Q.
Yes. What's the example?
Okay, let me just check my example 1. It's d squared y over dx squared.
Yes.
Minus 3 dy over dx plus y is equal to 4.
It's equal to 4.
Yes.
Let's that one is when you have got a number. I need the one that has got equals to 0. Go to the one that has got equals to 0. For now,
Okay.
I'll do it as equals to 0. I'll get to this one. For now, let's focus on this one. Look for the
Okay.
one.
Okay.
Look for the one inside your study guide. Look for the one that is created to 0 because that's where we start.
Okay.
Look for the one that is equated to 0 because the one that is equated to 4, where you've got 4 here, you have to find auxiliary equation, and your particular integral, your pi. If you check there,
Okay.
they found particular integral and the auxiliary equation. But for now, since it's equated to 0, we're only finding the auxiliary equation for now.
Okay.
Sharp.
On my study guide, I find this under module 2, second order differential equations, learning unit 2.
Okay, yes, please go to the one that is equated to 0. Give me that sum, that equation. The one that
Okay.
they need
No.
to start you with the one that is equated to 0 before they go to the.
Oh, okay. Okay. Wait.
The one that he's looking for is on page 35.
Yeah, go to page 35. The numbering will be different, but then
Oh, all right. All right.
yes,
Okay.
I'm looking for the
Okay.
one that is equated to 0, not the one that is equated to this. The numbering will be different. Please don't focus on the numbering. Go to your first order differential equation, second order differential
Okay.
equation.
Okay. Okay. No, then I'm sorted because if it's on page 35, I think I was on page 52.
No, don't
It
go to
says.
page 52. The numbering is different. This is the all study guide. Yours is
Okay.
different.
Okay. Then my example one on page 35 is d squared y over dx squared plus dy over dx minus 2y is equal to 0.
Yes, that's exactly what we are doing now.
All right. All right.
Sharp.
Thank you. Thank you. Thank you. I think we're on the same page. All
Sure.
right.
So guys, since after doing this, the reason why we are only focusing on this one, the one that is equated to 0. If you see that it's equated to 0, guys, it means you have to find only the auxiliary equation. The auxiliary equation is where you change everything to m, and then from there you find your linear equation. So the linear equation, this is how you're gonna do it. The linear equation, this equation that I'm gonna write here, guys, please note that only you only use this equation. You only use this equation when you have different factors. You only use this equation when you have got different factors. Ne? From your auxiliary equation. Guys, please mute your mic if you are not asking a question. You'll only switch your mic when you want to ask a question because I can hear there's a noise in the background. Please switch your mic off in the meantime. Then if you've got a question, that's when you switch your mic on. Yeah. Then after asking that question, you switch it back off. So different factors from your auxiliary equation. The auxiliary equation I showed you that it's your m when you change everything to m. So this one, guys, this equation y equals to c1 is this equation there that I've just highlighted. This one. I don't know the page number, but then you'll see it. I've just highlight this equation and write on the side there. You see this equation, general solution. This one, the general solution of this. Where is it? Uh, they didn't write it here. Okay, but this is the equation. I wrote it. Oh, I wrote it here in the book. I wrote it in the book. C E M1 X plus C2 E M2 X. So this will be the standard formula for general solution, for your general solution GS. This is for standard equation if your factors are different. Only if your factors are different, this is when you use this equation. Do you guys understand that part? Only if your factors are different, please. So you're gonna put those factors that you found for M1 and M2. It doesn't matter even if you swap them. Even if you sub this, it's fine. Even if you swap your m1 and m2, it doesn't matter. It's fine. So your equation in this case is going to be c1 equal c1 e to the power m1. m1, it was minus 2x. Then plus c2 e, your m2, it was 1. And then you're going to say x there. That's your general solution. Only if your factors are different. And then also, if your factors, if this thing is equated to 0, that's when you get to this part. That's your general solution. You stop there. Then now let's go to this one. You see this one also. For this one, your factors will be different because it will be 2 and 1. Okay, we change everything to m. Minus 3 m plus 2 equals to 0. That's the first thing that you do. That's your auxiliary equation. This part.
Mr. Machete.
Yes.
Sorry, man. Can I just ask what happens to the y if you write 2 there? What happens to the y? Maybe I just because I didn't really study that, but what happens to the y?
To this, which y? This one.
Yeah, there by 2y. Why do we have 2 now?
You only take the coefficient. You ignore the other values. You will see when do we use that y. You will see when you get to particular integral. When you get to particular integral, that's when you're gonna use that y. For this one, you ignore this. You only take the coefficients. The coefficients is the number that is in front of that function.
Okay.
So you only take this. You see here, if it's 1, here it's 3, here it's 2. You ignore the dy and what. Yeah, that's what you do. Okay? Do you understand it?
Okay, thanks.
Sure.
Yeah. I get it.
Sure. Let me. Okay. So now we're gonna do this. We're gonna find factors for this thing. This one is easy. If you can't find them, if it's difficult, I said you must use quadratic equation. So it's 2 and 1 equals to 0. So you need to check which one is positive, which one is negative. So as you can see, they must be all negative because it's minus 3. The middle term is minus 3. Then if they are all negative, they will give you positive 2 if you multiply them. So now your m1 will be equals to 1, and then m2 will be equals to 2. Then you see the factors are different now. This is the equation that you use, your general solution. You're going to get to this. You're going to say c1 e to the power m1 plus c2 e to the power m2x. You put x there. Don't forget that x. Then you substitute your values now. Ce, you say x plus c2 e 2x. Then you are done. That's your general solution. You see, you end here because it's equated to 0. You end here. You only find this one. We'll get to the point where it's equated to something. For now, let's focus on this one. Then the next one, guys, is there any question up to so far? Before we go to the next equation, to the next method of finding the second order differential equation. Is there any question? Any question? So now, the next one, it's your, I think it's where you have got different equal roots. So equal roots, so when you've got same factors. When you've got same factors, this example, you've got same factors. I will do 2 examples for each so that you get used to these things. So this one is when you have got same factors. Same factors. You see there, you'll get same factors for this one. And there's what I'm going to show you this one. Do this one. D squared y over dx squared minus 4 dy over dx plus 4y equals to 0. So you're going to have to find the factors of this. You change everything to auxiliary. You're going to say m squared minus 4 m plus 4 equals to 0. Then you find the factors of this. So the factors of this will be 2 and 2 to give you the middle term. Let's put minus, minus. It's minus 2 and minus 2. You see these factors, they are the same. These two factors are the same. Then this is what you're going to do. You're going to say m m1 is equals to m2 equals to 2. Then this is what you're gonna do, guys. For your, it's up to you guys. I see they can, you can change this thing and say m minus 1 all squared equals to 0. It's up to you. You can do this. It's up to you. Doesn't matter. For okay, so now you see the factors are the same. I'm gonna write here same factors. For same factors, you use this equation. Your general solution, you're gonna be this equation: C1 E M1, okay, plus C2 E M2X. You see this, you're gonna say multiply by X. Multiply by X. This X is very important. You multiply the second equation, multiply by X. You see the difference between the first one and this one. The first one, it did not have this X. For this one, because this equation is the same as the previous one, where you have got different factors. The only difference is that when you have got same factors, you multiply by X. That's the difference. Same factors, you multiply by X. Okay, this is what you're gonna do. You're gonna say y equals to C1E2X plus C2E2X multiplied by X. This is when you've got same factors. That's the equation for same factors. Does it make sense? Yes, no? Yes, no? Does it make sense?
Yes.
Okay, thank you.
Yes, it does.
Sure,
Thanks.
sure. I'll look for something. You see, that's what they do. You see how they got that? Yebo.
Can you show that step again, please?
Okay.
Last one.
Don't worry, okay. The last one, which one?
Now, the last part, which is the answer. Oh, I just wanted to check the x is still there. It's not at the as the exponent or anything.
No, you multiply. You leave it there. You multiply by X.
Oh, okay, you leave it there. So you don't substitute by anything.
No, 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 no. That's your answer. You are done.
Oh, okay.
Yeah, yeah. So let's do another example where you've got same factors. Uh, you need something. You need something that has got, that can give you same factors, that you can multiply and then they'll give you the middle term. You need those things like your 64, yeah, like your 49. Those things. That's what you're looking for. The one that can give you the same factors.
Okay. How about it should be x squared, or should I say m squared?
Yeah.
M squared plus or should I say minus 6?
Minus 6.
Yes.
Mm.
Plus 9.
Plus 9. Yes, that's exactly what you're looking for.
Okay.
That's exactly, you're gonna get same factors. When you multiply 3 and 3, it will give you 9. And then when you add minus 3 and minus 3, it will give you that positive, negative 9, I mean. So let's write, it's m squared minus 6m. We can change this. I just write minus there, then 9, and then you keep this thing to 0. So you need to know which one is your negative, which one is your positive. So in this case, we're gonna put negative and negative so that this one will be positive. So here we're gonna have m minus and minus. Okay, you're gonna have 3 and 3. Obviously, originally this equation, it will start like this. It will be d squared y over dx squared minus 6 dy over dx plus 9y equals to 0. That's the original equation. So we just wrote it in the form of auxiliary equation. So hey, let me change this 0. This 0 looks like 6. Then you're gonna say m1 equals to m2 equals to 3. Then Since the factors are the same, C1, E, it's easy guys to memorize this thing. You just multiply by x there. That's the only difference. You see, this problem will start when we start doing the theorems. Hey, that's when the problem starts. The theorems, we're gonna do them when this thing is equated to something, not 0. EM2 x. Then you multiply by x then. And then C1 E. And then you're gonna put 3x plus C2 E, 3x multiplied by x. Then you're done. That's all, guys. That's all you need to know. Any question? I did 2 examples, then we move. We move to the one that I was talking about, where you've got complex numbers. Any question? Okay. Seems like there's no question. So the next one is when you've got complex numbers. Complex numbers as your factors. Complex numbers. So complex numbers, guys, it's when you've got a square root of -16. That's your complex numbers. You can't find the factors of this thing. Let's say, for example, you've got your m. When you try to find your factors, your m will be equals to plus or minus square root of -16. -16. This is what you have to do. Because you can't find the negative square root, you must remember that from your basic maths, square root of a negative number, it's I. This I means your imaginary number. Imaginary. So you replace square root of -1 with I, or imaginary number. So this is what you're gonna do. You're gonna have to change this. You're gonna do this equals to plus or minus square root of 16. You make it positive so that you can be able to find the square root of that number. Then you multiply with your -1. This thing will take you back to the original equation, which is this one. You're gonna multiply those values inside the square root to take you back there. So this is what you're gonna do. You're gonna say plus or minus square root. Square root of 16 is 4. And then instead of putting square root of -1, you're gonna put I. That's your imaginary equation. Imaginary or complex numbers. That's how you do it. This one is when you can't find factors. If you put those values in your calculator, they'll give you error. And then they normally you normally use quadratic equation for this, for such functions, because you can't find the factors. When you use quadratic equation, you're gonna get a negative square root. So you use this equation. This equation will tell you that this is a complex number. So you must know what to do. Then this equation, guys, it's on page. You see they say roots complex. That's the chapter that you are doing now. Then there's your quadratic equation. This equation that I'm talking about, not this one. It's this one. It has got sine and cos. It's this one. This is your equation. You must know this equation. Please highlight it. I don't know what's the page number on in your book, but then this is the equation. For this is your general solution equation for this one. So can take notes. This is for complex numbers. If you've got a negative square root, the moment you see I, this is the equation that you use. This is the equation that you use. EAX, open bracket, cos bx plus sine bx. Then this bx and what, don't worry about them. Let me write something for you. You see this, guys, I used the wrong one. When you try to find factors, you'll get to m is equals to a plus or minus bi. It's the same as this. What I just wrote there is the same as this. is the same as that. Your okay, let's do one example. That's 16. Let me take the same example so that it can make sense to you guys. I said plus or minus 16. So in this case, guys, since I'm applying this formula here, m is equals to a plus or minus bi. In this case, after solving this, I'll get 4i. So they tell you that the one that has got I, it's your B. And then the one that is before the plus or minus, it's your A. So in this case, our A is 1 because there's nothing there. It's 1. If there's nothing, it's 1. Sometimes you'll find equations like this. It's equals to 2 plus or minus 4i. And then for this equation, when you use quadratic equation, guys, this is from quadratic equation. Your A will be this one, then your B will be this one. Does it make sense?
Yes.
All right. All right. Let's move. This is your first example. We're gonna do this example and one application from your exercises. There's a lot of examples that you can do, guys. This you just select it randomly because I just choose any example that can give you a negative square root. It's easy to know that. Okay, let's do that example 5 there. Then we're gonna do another example that we from our we'll just come up with that example to show that you guys understand. You'll give me that example like the previous one, or I can do it myself. But I want you guys to do it to show that we are together. It seems like we're gonna finish this today. Then we can for dy over dx. If you have got a question, please ask. Please ask, guys. Guys, look at this. You see this? How do you know? Look at this. If you can't find the factors, okay, let's change everything to m. That's the first thing that we do. Equate it to 0. Look at this equation. What are the factors of 8? The factors of 8 that can give you 4. The factors of 8, you can write them down. You say 8 times 1, and then 2 times 4, and then there's no other factors. It will take you back again. So all this, when you add 4 and 2, it don't give you it don't give you 4. When you add 8 and 1, it don't give you 4. So it clearly you have to use quadratic equation here. That's how you check. So quadratic equation, you'll have your m equals to minus your a is 1, your b equals to 4, and then your c equals to 8 using the quadratic equation. So this is ax squared plus bx plus c equals to 0. That's how that's your a, that's your b, and then that's your c. I used that equation. You need to know this quadratic equation by heart, but then I think it's there on your formula sheet. The only thing that is not there, it's your second order differential equation over 2a. Then we can substitute the values now. Our b is minus 4 plus or minus square root. You will see, guys, to show that it's a quadratic equation, you must compare your the value of a and c when you multiply them with 4. If they are higher than your b squared, then that's when you know that it's a complex number because it will give you a negative. So what I'm saying is that your c, if your c is higher than your b, if your c is higher than your b, when when you multiply c with a times 4. Guys, obviously this will be a negative square root there, because when you square your b, it must not be lower than 4ac when you multiply them together. If it's lower than that, then it means it's a negative square root. So as you can see, guys, I'm busy erasing this thing. Let me leave it like that. Your b squared, you're gonna say 4 squared minus 4 into 1 multiplied by 8. You see there, 4 times 8 is something else. So this 4 times 8, it will be 24. So your m will be equals to minus 4 over 2, then say plus or minus square root of over 2. So I'm splitting this thing into half, guys. I'm splitting this thing. And there's a reason why I'm splitting it, because I'm going to get a negative square root here. So you split it like this. This 2 is this one, and this one also. That's your LCM. So there I'm going to get 16 minus 24. Then, is it 24? Yes, 4 times 8. 16 plus 8, yeah. And then you can subtract there. So here you're going to get minus, you see 4 and 2. So you're going to divide them. You're going to get 2 minus 2 plus or minus a square root of.
How do you get 24? That's 32, and 4 times 8 is 32.
Is it 32? Oh, yeah.
Yes.
I said 3 times 8. It's 32, yes, sorry. It's 32 because it's 16 plus 16. Okay. Then you're going to get minus 2, and then plus or minus a square root. I'm going to write a negative square root of 16 over 2. From here, guys, you have to change it. You have to change that thing. You're going to say m equals to minus 2 plus or minus square root of 16i. 16 over 2, right? You understand this part, right? I changed everything to square root of negative 1. So your answer for this one will be equals to minus 2 plus or minus square root of 16. You're going to get 4. 4 over 2, you're going to get 2. So you can do it the long way. But guys, I don't like doing the long methods, because for this maths you don't have time, ne? So you're going to get square root of 4, square root of 16, which is 4, 4 over 2, then, yeah. There's no need for you to show all the steps, guys. This is math 3. Math 3, don't, hey, otherwise, time. Remember, I've got only 2 hours to write the exam. Plus or minus, okay, why am I writing this again? So I just want to show you that this is your A plus or minus BI. So we are done. We are done. Then you're gonna do this. You're gonna write your equation, your general solution. That equation for your general solution. It's EAX. Okay. Is it minus or positive AX? Where is that thing? It's positive. Okay, no, it's fine. Positive AX, then C1 cos BX plus C2 sine BX. And then you substitute your values. You've got your A. Your A is this one, which is 2. Then that B is this one, which is 2, positive 2. And then your A is negative 2. Then you can simply go there and say negative 2x C1 cos, what is your BX? Then your BX is 2x plus C2 sine 2x. Then you are done. You can remove the brackets if you want to. You can leave it like that. There's no need for you to go further from there. You are done. Any question? Any question? That's how you do it, guys. That's how you do it. Okay. It seems like there's no question. And the next part, I'm not gonna do all the examples. You see there? I'm not gonna do all the examples. You see example 6, you've got different factors. You've got
Can you please go back a bit on that example?
on the slide.
Just wanna see the answer. Okay, thank you.
Okay.
Okay, pardon me. We have a on that equation that you have in the same example. Yes, you've got m equals to a plus minus b I. What happens to this plus minus? Where do we slot in the plus minus here?
No, the plus minus it. No, that one. There's no need. There's a complex number, so it tells you that your value can be a plus or minus.
All right.
Yeah, no, it doesn't apply here. There's no need for you to say, let m is equals to minus 2 plus 2i, or m is equals to minus 2 minus 2i. No.
Okay.
Yeah, sure. From there, you just plug it on that equation. So another example, guys. You can just come up with an equation. You say m squared plus 2m plus, obviously, if you put 6 here equals to 0. Look at this. When you take your, this is how you check that it's a quadratic equation. For AC, if you take your A, you put 1 there, and then your C, it's 6. Obviously, your B squared, you compare, you check. Your B squared, it will be 2 squared, which is equals to 4. So you're going to have B squared minus 4AC. So this will tell you that if you take B squared, you say 4 minus 4 times 6. You see, 4 times 6, you're going to get 24. So you see there, you're going to get a negative square root of 20. And then you know the story. You know what to do there from there. Do you want me to carry on with the example, guys? Or we can skip it? You're sorted. The second example, where you've got complex numbers. You want me to carry on with this one? Or I can leave it here?
I carry on, please.
Must I do it?
Yes.
Okay. No, it's fine. It's fine. I already found the factors. So I'm gonna say m equals to minus b plus or minus square root of b squared minus 4ac over 2a. Your m will be equals to minus it's minus 2 plus or minus square root of 2 squared minus 4 multiplied by 1, which your c, which is your a, and then 6, all divided by 2a, which is 1. Your m will be equals to minus 2. Okay, I'm splitting this thing over 2 plus or minus square root of 4 minus this 24 divided by 2. Then let's go. I'm gonna write it's a minus 1 when you divide minus 2 and 2. Okay, plus or minus square root of minus 20 over 2. This will give you minus 1 plus or minus 20i over 2. Then therefore I can conclude now and say, therefore my m will be equals to minus 1 plus or minus 10i, where this minus 1 is your a, and then your bi equals to 10. Then since it's a complex number, your equation said it's gonna be EAX open bracket C1 cos BX plus C2 sine BX, because you only use this equation again for complex. They say roots, complex roots, or roots and complex, something like that. But you'll know it's a complex number. Then you're gonna substitute those values. What is your A? Your A is -1. So you're gonna write minus x there, because minus 1 times x, yeah, it's minus x. C1, it's cos, and then 10x plus C2 sine 10x. 10x. Then that's your answer. That's your general solution. You are done. Any question? Any question?
No.
How did you get the plus minus 10 from square root 20? Yes. What happened to the square root of 20? Does it mean
Oh, sorry. 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 Sorry, you have to put that square root. Ish. I removed. Wait. I removed the square root. Sorry. Sorry. Sorry about that. Sorry about that. Sorry about that. I removed. The reason why I removed the square root was when I was putting this I forgot that the square root has to remain there, because you will get minus 20. This will give you minus 20i, square root of 20i, when you remove that minus 1, minus square root of 1. So you're going to square that 20. Sorry about that. The square root of 20, you're going to divide it by 2. Then you'll get your answer.
Square root 5.
Yeah, to give you root 5. So you put root 5 there. Thanks, man. You put root 5. At least, guys, you have to comment. You see now, it's easy to make mistakes. You put root 5 there. You put root 5 there.
How do we arrive to root 5 again?
Oh, the root 5. You see here, I made a mistake. Instead of squaring the 20, I didn't square the 20, because I made a mistake when I was replacing the I. So let's go to this page. It was negative square root of 20 divided by 2. So this is how you solve it. You don't want this negative square root, so you're gonna say 20 multiplied by square root of minus 1 over 2. Then where the square root of negative 1 is equals to I.
Yeah.
So we're gonna have square root of 20i over 2. Then the root 20, you're gonna say root 20, it will give you 2 root 5 over 2. Then this 2 and this 2 will cancel. You'll be left with root 5. You put I, don't forget to put I there. Then that's how you arrive there. I made a mistake and not replace that square root. I made a mistake and leave that. I left the square root out. You have to put it there. Do you understand it now, man?
Yes, I'm following. Thank
you. Sure. Any other question? If you need more examples, guys, please let me know. If you need clarity, please let me know. Any comment, any question, any query? Even if you want to add something, you're welcome. Let me see the messages. Someone sent a message here. What's happening? Oh, okay. No, it's fine. Guys, yeah. Let's work. Let's operate. Okay. So, what's the next step? I think now they are doing the application. Guys, even if they are doing course, it's easy, man. It's easy. You see here. Okay, I think we have to do this one. Where you've got for cosh. Remember we're doing for sine. Now we're gonna do for cosh, for your hyperbolic functions. Hyperbolic functions is when you have got same factors but different signs. So remember this equation. I'll show you. Let me just do this. You have got same factors but different signs. So this is what you're gonna have. You're gonna have m1 equals to -1 and m2 will be equals to 1. You see the factors are the same but different signs. You're gonna have something like this. Then this you'll get it normally where you have got plus or minus 1. Obviously this, if you say plus or minus 1, it means your m1 is not equals to your m2. Although the values are the same but the factors are not the same. The other one is positive, the other one is negative. You'll have cases like that. So like this. You'll have something like this. Or you'll have a square root. You'll have something like this. M squared plus 49. Okay, let me say not say plus. Minus 49. Let me do those two examples. I'll show you. 49 equals to 0. When you take it to the other side, you'll have 49. Then obviously you want m. You don't want m squared. So you're going to have to square both sides. So you're going to get plus or minus 7. You see this? Same factors, different signs. That's the one that we're going to do now. Don't worry, we'll do a lot of examples on this. This is the formula that you're going to use. Where is that formula? There should be a formula. This one. You see now, they don't write it. You see here, hyperbolic identities. Hyperbolic identities. That's your hyperbolic identities. Nothing complex there. Nothing is complicated. It's easy. You see, that's your general solution. I just wanted to show you that if the factors are the same but different signs, you write it as it is. There is it. The only difference is that the other one, the factors were the same and the sign was the same. So instead of putting x here, you don't put multiply by x because the factors are not the same. They are the same but different signs. That's what I mean. Is it necessary for us to do it? Yes, no. Is it necessary?
Just one example, perhaps.
Sorry?
One example, perhaps. Would do.
One example.
Yes, sir.
Okay. No problem. I'll take this one. This one. So you've got m squared minus 49 equals to 0. When I found the factors of this, I got plus or minus square root of 49, which gave me plus or minus 7. Then I said because the factors are different, you're going to use this formula. M1x. Remember here you're going to get m1 equals to minus 7. M2 will be equals to 7. So you get two values there. It's not different from the one that we did. Different factors. That's what I wanted to show you. Factors are the same, but different signs. So it's more like this is the same as when you have got m1 equals to 2 and m2 equals to 3. Is the same as...
I'm following that, but how do we get to plus minus 40 square root of 49? Is it not 49 isn't supposed to change sign to positive when it crosses the.
Yeah, it's positive, again. It's positive. It's positive. Remember, the moment you introduce a square root, you're gonna get a plus or minus. You remember that part?
Oh, okay.
Let me show you. Let me show you the easiest way. Wait, don't worry. I got you. It's m squared minus 49 equals to 0. What are the factors of 49? This is the same as, this is the same as, then you can write it as,
Oh, okay. All right.
now you remember. Then you're gonna say m1 equals to 7,
Yeah, that's correct.
m2 equals to minus 7. So it's the same as m equals to, you take 49 to the other side, then you say 49. The moment you introduce the square root, it will tell you that you should get plus or minus square root of 49.
Noted.
Sure. So I wanted to save time, yeah, shortcut. Does everyone get that part? Do you guys get it? What he was asking?
Yes, I got it.
Sure. All right. Let's work. You see now. Maths one guys, they're busy commenting the Telegram. How do you mute this thing? I want to close the Telegram thing. Okay. Where was I? Okay, so you're just gonna replace those values here. It's the same. You understand the comment that I made on the site here? This comment that when you've got same factors, different signs is the same as when you've got different factors with the same sign. Like you've got 2 and 3. It's the same. Use the same formula. Note that comment. Write it down or something. So you're gonna get minus 7x plus C2e 7x. That's how you do it. I don't think there's a question. We are done. That's
So
what
you only multiply by x at the end when
they are the same.
the vectors are the same.
Yebo.
Okay. All right.
Yebo. Then this is where the problem.
Can you please go back to the solution of the last example, which you did? The one you wrote, yes, the one you wrote. I just want to.
Okay, no, it's fine. I done. You let me know. Take your time. You let me know when you're done. Take your time.
All right.
Sure. Guys.
No, okay, no, I'm done.
Someone is asking if the meeting is getting recorded. Yeah, I'll send. I think it's still recording. Let me check. I think it's still recording.
Yeah, still recording. I see on my side.
Yeah, you see here. It says, yeah, recording. Okay, where was I? I was here. So now, this is the part that I was talking about. Do you see now? Look at this. Now you're going to have to find the particular integral. Then you also find your complementary function. Your complementary function is when you're doing your m1, m2, what. This is where you apply the theorems now. Now we're going to work, guys. You see that example that we're talking about where is equated to 4. This part is still the same. The difference is that your general solution will still be the same. The only difference will be now. Now you've got, it's equated to something. It's not equated to 0, like, like okay. It's not equated to 0 like your first one. So I'm gonna take, where is that thing? I want to take something. from this book. You can take any equation, a random equation that we did earlier. So someone will tell me, I'm gonna take this, the one that we just did now. I want to show you something. We're gonna say 49. Then we equate it to 3. You see now the difference. This one is equated to a number or a constant. It's not equated to a zero. This is the difference. So when you see this simply, obviously, guys, don't forget that this thing will come as d squared y over dx squared minus 49 y equals to 0. Equals to, no, not equals to 0, equals to 3. Original, this equation will be like this. I'm just taking shortcut to write it in the form of auxiliary equation. So this 3, just because you've got that 3, it means you have to find.
Are you right? On my side, because there is nothing that is appearing on the screen.
Yeah, I think maybe
it's
there's
just m squared.
I think maybe there's a network problem. I think, is it? Are you the only one? Let me ask.
No, she's not.
Sorry.
All of us.
Yeah.
Is it appearing now?
No.
Okay.
Yeah.
Is it appearing?
Yes.
Yes, it's appearing now.
Please tell me. I think there's a it's the network. Let me do this. I'm gonna write something. Please let me know if it will appear immediately. I'm gonna write 2y. Do you guys see 2y?
No.
Okay.
No, we don't.
Let me refresh the network. I think maybe.
It's appearing now. Now it's appearing.
Okay, let me refresh the network. It's fine. Let me refresh the network. Hopefully. Yeah. But if I refresh it, wait. I don't think. Will it not affect the recording? Hey, let's not take chances. Let me. Should I save the. Hey.
Surely it will affect it.
That's the problem. Okay. Okay.
Would rather not refresh it.
Hey, yeah. No, I don't know. Okay, 3y. You see it, right?
No, it's appearing now.
Oh, it take time. It take time to appear.
Time, yes.
Yeah, there's a delay. There's a delay. Okay, no, it's fine.
Yeah, it's like a 3-second delay.
No, let's work then. I'll be slow. I'll talk slowly. Because I don't want to take chances and refresh the network. Otherwise, if it disturbs the recording, guys, it's a problem. The other guys will kill me. Okay.
Okay.
So, guys, just because you've got that 3, the equation is equated to a number or a function. This is when you know that you have to find particular integral. They normally write it as pi. So, for particular integral, I'll show you how to do it. Let's do this. Let's do this example. We're gonna do the one in the study guide. So now you follow the same steps. I'll show you the part where it says particular integral. So for this one, guys, we found y equals to. I'm not gonna do that part. You do it step by step and then you get your general solution first. So you're gonna find the general solution first. To find general solution, this is what you're gonna do. Let me erase everything. Let me just do it. So you're gonna say m squared equals to 49. You see this thing, you're gonna remove that 3. I'm saying let me do it, but then I'm busy changing this. You're gonna remove that 3 and put it on hold. You're gonna put it somewhere, leave it. You're gonna ignore it. You find your auxiliary equation like we've been doing. There's your auxiliary equation. You find that auxiliary equation. You put it that way. You remove that 3. You equate it to 0. Whatever function, it can be 8x squared plus what after that equal sign. On the right hand side, it can be any function. You remove it. The first thing that you do, you remove it. You find the factors of that thing. So for this one, guys, I'm not gonna do it further. You're gonna find your general solution. Your general solution, your sorry. In this case, this general solution, they call it complementary function. You know why they call it complementary function? Because at the end, your general solution is gonna be your complementary function plus your particular integral. you're gonna add the two equations. So basically, just because now you have got this side, your right hand side and your left hand side, you're gonna have to find two equations. So you're gonna find the equation for this one. Previously we were saying general solution because it was equated to 0, but in this case we can't say general solution is the first one because now you've got two equations. General solution will be the sum of the left hand side equation and the right hand side equation. Do you guys get that part?
Could you please repeat? Didn't get that part.
What I'm saying is that this time
Now this is speaking Greek now.
I know now we are doing the application. We were doing basics, now it's applications, ne? So I'm saying your general solution, you will add, you will see it when I do it. For now it won't make sense, but when I do it, it will make sense. Let me do it and stop talking, because when I explain it won't make sense, but when I do it, when I take action, it will make sense. When I do it, it will make sense. So now let's find our y. This y, I'll call it ycf. That's your general solution. We're calling it general solution. So here we found c1, right? E to the power minus 7x plus c2 e 7x. We stopped here. That's the first part, that number one. Now just because it's equated to 3, I'm gonna say this step 2, because it's equated to 3. Normally if it was equated to 0, we stop here, but just because of it's equated to 3, this is what we're gonna do. You're gonna say y equals to 3, right? That's a constant. And then this constant, where there's 3, we're gonna replace it with a. The reason why they replace it with a is the first letter. Let me show you. I'm going back here. Let's say the whole equation was equated to 3x squared plus bx. Sorry, not plus bx, plus 2x. You see that this is a quadratic equation. You can write this as ax squared plus bx. But if it was 3, then you don't have x there, you just write a. If it was 3e to the power x, you just write it like this. Where there's a constant, you write a ex. If it was like this, if it was like this, 3x squared plus 2, this is what you're gonna do. You're gonna say a x squared plus uh, what's the next one, plus c. You know why I say plus c? Does anyone know why I'm saying plus c?
Because there's no
There's no
X
x.
in
Yes,
place.
there's no x. My middle term here, it will be maybe 0x. Is 0x.
Yes.
Yes, thank you. At least we are together now. So now we can work. Does anyone have a question before I go back to the actual equation? This should be our last example because it's almost time. Yes. Yeah.
So Dave, sorry, you are saying where you are saying y is equal to 3, ne?
Mm.
It's equal to it's the same as a, because that equation, if it was in the form of a quadratic equation, it would have be just a number, just one number or what?
Yeah, because it's a number. It's just a number. That's why I'm saying a.
Okay.
If it was a quadratic equation, but like 3x squared plus 2x, it was gonna be ax squared. So you replace that number with a with an alphabet.
Okay.
Where there's a number, you follow the sequence, like a b c d. If
Yes.
there was 4 numbers, it was gonna end at d.
Okay.
If it was like, for example, 3 cubed, 3x cubed plus 4x squared plus 2x plus 3. So it was gonna be your first term, ax cubed, until you get to d. You're
Oh.
gonna You're gonna write D because of it's 3 alone. Because this 3 is sitting alone. It's just a. It makes sense now, ne? Okay. Mm, yeah. And then Kanakimang, who asked the question? Who asked the question?
Bongeka.
Oh, okay. Your voice is similar. I thought maybe it's someone else. Is Bargamang was who's that person? There's this person, man.
I wonder who it is.
Zanele. Oh, Zanele, you are here. It's Zanele.
Okay.
I'm worried I didn't hear Zanele today. Zanele, are you sorted or what's the story?
No, I am sorted. I'm okay. Thank you.
Don't worry, we'll have a. If you're not sorted, you know the story. We must have a session, another session.
Right.
Sure, we'll have to arrange private one. We'll talk. No, you know what happens. You know what happens. Zanele, Zanele is a private client. So this one I'm just giving you guys. So them they get other
So
sessions.
she's one of the private session students.
No, she's agree here. It's just free for you guys.
Uh-huh.
For them, it's a private because
They're paid.
they are paying. Yes,
Okay.
so they get more sessions. They get 4 sessions for the whole month. I'm only doing like I was supposed to do 1 session, but then I said, let me do 2 for this month. Then the next session for you guys it will be next month, sometimes first week.
So we have to beg your generosity. How about we as the non-payers get 2 sessions a month?
Ah, it's one. Must I not pay? Oh, this guy. I'm assisting. It's just me assisting you. I'm just assisting.
Listen. Some of us just got laid off at work, man. That is why we're trying to push the second qualification.
How but bruh, look, I'm assisting. I'm just giving you a free session every month.
Yeah, but blessed is the one that gives or the hand that gives.
But I'm giving already. Amara, guys, let's be honest. Zanel, Amara, let's be honest. But let's be honest, guys. I'm trying. There's no one who's gonna give you free session for like.
You're trying your best.
I'm trying every month. I give you 1 session.
No one does, Jay. No one does. Thanks.
And those sessions are working.
But guys, at least I'm trying rather than being quiet. At least I gave you enough information like today. Imagine I gave you like bruh, you're not gonna get this information anywhere for free.
Yes, we appreciate.
But guys, 2 sessions.
Because last time you gave us a session, there was an assignment that was due, and that assignment I did it.
And I was assisting you guys with that assignment. Imagine. I was guiding you. But guys, it will be unfair to Zanel,
And
to
it
those.
was very easy to do that assignment.
Yeah, for those who paid, it will be unfair, my guy. It will be unfair because for them, yeah.
What are the figures again? Maybe we might contact our own sharks.
Bruh, it's 270. It's 270. Affordable, not that bad. 4 sessions a month.
270 a month.
Yeah, for the whole month. You get 4 sessions. It's not that bad.
Okay. And how do we wire the payments? Or maybe we should discuss this like private.
Yeah, it's not a problem. Sorry?
So once we have paid, you add us on another group or what?
No, it's the same group, but then you will get sessions. They're not gonna get sessions.
So how will you know which one paid when?
Obviously, I'll send you a link. I give you I give you an invoice. Then I've got all the list of people who paid. Yes, that's how it works. I'll know. I'll send you a link for attending separately. I'm not gonna send it on the group. I'm not gonna send it.
I want to join from this month. I want to pay there.
Yeah, then you can contact me. It's fine.
Okay, okay.
Yeah, Zanele knows. I send the link separately for them.
No, Zanele should say.
Okay, so
The information is given.
Mr. Matlak,
yes,
I see there's APM 3700 here. What's happening? There's a session also that side.
APM what?
APM for numerical methods. Do you have sessions?
Hey, bro, I'm still arranging that, bruh. Yeah, it's getting there because I got someone, but then that person, she was studying at VETS, ne, doing civil engineering.
Yeah.
So now I asked her to assist you guys. So I'm still arranging it because it's, it's a she has to go through your module before she can give sessions. I'm still talking, yeah. But as soon as it's on, just get ready because she said she will do it. But then yeah,
Okay.
I'll tell you when.
All right. No, we will soldier on in the meantime.
Yeah, in the meantime, just push it on your side. Okay. Yeah, so yeah, I'll send the link. I'll upload the thing, the video on YouTube. But only this one. For private session, I'll send it personally. Guys, okay, let's work. Hey, let's work. We spend more time talking, guys. Let's work. I want to finish this thing. It's almost time. Okay. So guys, I said you have to change everything to y. To y equals to a. After doing this, guys, remember this equation. It's very important that you write this equation like this. Because why? And like, let me go step 2. Let me write it here. So I said y equals to 3, and then I equated this 3 to a. So y equals to a. After doing this, guys, you're gonna have to find the first derivative and your second derivative of that a, of this. So you're gonna say dy over dx equals, what is the derivative of a constant number or a constant? How do you
The
differentiate?
derivative of a constant is zero.
Is 0. Thank you. And then again, you're gonna find the second derivative of this. Obviously, when they say second derivative, you're gonna have to find a derivative of your first derivative. So you're gonna have to differentiate 0. You're gonna get another 0. If it was like this, it was ax squared, then the derivative of this, it was gonna be 2ax, the first derivative, and then the second derivative, it was gonna be 2a. You get the point?
Yes.
Sure. Okay. Then you saw that formula that I wrote on the corner there. It's very important, this formula. You see there, I'm gonna have to go back to this equation and substitute my values there. So let me write it. It was m squared minus 49 y equals to 3. It was equated to 3. So in the form of the derivative, it's dy over dx squared minus 49 dy over dx equals to 3. So you're gonna substitute those values this back to the original equation. So you're gonna put 0 there. Minus 49 into 0. Oh, I forgot to put sorry guys. You see this 49, it's y. It's not, it's y. Sorry. Sorry about that. It's y. So you're gonna say equals to 3. You see now? Then this is when you work with y. You see y equals to 3 over minus 49. This is your ypi. This is the particular integral part now. You see I've got two equations. You have got the second equation and the first equation. So after finding this equation, guys, that's when you go back to your general solution. There's you combine them. You're gonna say your YGS. I normally say YGS because it's my general solution. You're gonna add your YCF, which is the first equation that you found. Normally we are saying it's an auxiliary equation, but then it's your general equation when it was equated to 0. But in this case, they call it complementary function. So the next one, it will be YPI. This YPI, we found it because of that 3. That's how you do it. And then YGS, it will be equals to your YCF. If I remember, it was like this. And then you're gonna add your YPI. Your YPI are found negative 3 over 49. I don't know if you can get negative 3 over 49 on the calculator. If you calculate, I don't think you can find it. Yeah, it just remains like that. So that's how you do it, guys. This part,
Hey, Dave, can you
yebo.
go back to the previous slide and explain again because I got lost somewhere. Please.
Okay, I know this one because it's an application. So I'm saying I'm gonna go to step number 2. I'm gonna start over. You understand this part, right? I'm gonna highlight step by step.
Okay.
Aye, man. I'm trying to make this thing straight. That part.
Yes, that part I understand.
Okay. So from this part, we go here. We're gonna write it on the side. We write y equals to a. Then we're gonna have to differentiate that a. That a, you
Yes.
treat it as a constant, just like a number.
Yes.
So when you differentiate a constant, you're gonna get 0.
Yes.
And then you find the second derivative of that 0. You're gonna get another 0.
Yes.
Then after getting these values, they take you back to the original equation. The original equation was like this. This was your original equation. Remember?
Yes.
On that original equation, you're gonna substitute your dy over dx and d squared y.
Oh. Okay.
And then in this case, oh sorry guys, what did I do
Yep.
now? What did I do? Ish, I made a mistake here. Wait. Now that you are mentioning it, you see where there is y. What was your y when you substitute back to the original equation? Your y was a.
Yes.
Sorry. Sorry about that. Your y was a. So now your a will be equals to this. This will be equals to a. And then you're gonna go back. You know why I'm doing this? For this one, it doesn't matter because the value, when you go back to substitute back to the original equation, yeah, y, you're gonna get the
Mm.
same thing. But then the reason why I changed it, it's because some equations are different.
Mm.
You'll get the one where you've got a lot of values. So in this case, where there is y, you're gonna put a. You see here, this. Then I'm
Mm-hmm.
gonna go back to that original equation, yeah, y, this one, this one.
Oh, so you made to a subject of the formula.
Yes.
That's why I got lost.
Now,
Oh,
now
okay.
that now that I know my a is this one, ne?
Ah.
This is my
Now you go
YPI.
back and substitute to a.
Thank
Mm-hmm.
you. Thank you. For this one, it doesn't matter. That's why I didn't have to do a. Even if you put a, it will be the same thing. But then
Okay.
the problem will be now if you have got something like this. If you had your a as you had ax squared, it was ax squared plus bx. It was gonna be a problem because
Mm.
this is your YPI equation, your particular integral equation. When you
Mm.
differentiate this, I'm just wrapping up, guys. 2ax plus b. This is your first derivative. Why am I doing this? This is your first derivative. Then your second derivative of that, d squared over dx squared equals to, you're going to get 2a. That's all. Then you're going to have to go back to the original equation. You're going to substitute those values. Obviously, you're going to get 2a. You're going to substitute as it is.
Mm.
You get my point?
Yes.
You're going to substitute as it is. So in this case, you take that equation, yeah, I'm just showing you an example. Yeah, dx squared plus minus 49 y equals to ax. In this case, I agree we said ax. So this ax, we can change it and say it's 4x squared plus 3x.
Mm.
So this is equated to this thing. I'm just showing you that it does matter when you've got complicated equations. So
Okay.
you want to put back 2a. there where there is d squared over dy minus 449 into your a. What is your a? What is your y? I mean, it's ax squared plus bx. You get the point that I'm trying to make now?
Mm-hmm.
You see, this one is different because
Yes.
your
It
y,
has two.
yeah, that's what we were gonna get to this one, but then because of time now, yeah, we'll do it some other time. There's more examples of those things. There's a lot of work to do. This is another theorem that you use. So yeah. Otherwise, any other question? Let me Any other question? Let me save this thing before I lose it. Any other question?